Hey y'all, welcome back. So today we are going to unveil kind of the culmination of everything we've learned so far in this unit, and that is something called the unit circle. I hope you guys are going to like it. But before we can really dive into it, I want to talk about something that you guys learned in geometry, and that was about these two special right triangles that have a certain proportion to their sides to help you solve when you don't know all the usual information regarding the sides and angles. So let's go over those two special right triangles first. The first one is the 45-45-90 triangle. So what I'm going to do is actually use Cammy's nice little tool here to make sure I get it looking right. Okay, so 45 degrees is going to be right about there. And then I will draw the other side going straight down. So there you go. So this is a 45-45-90 triangle. And what's nice about this is that the two 45-degree angle measures are equal. So what we can conclude from that is that their opposite side lengths are also equal. So if this is 45 degrees, let me go ahead and type that out. So that's 45 degrees. Let me copy over a degree. Can I just copy that? Nope, it's not going to let me. That's okay. One moment. All right, here we go. Let's throw that in there, 45 degrees. Okay, so that's 45 degrees. And then we'll go ahead and copy and paste that to the other one. Oh, okay. Maybe not, maybe not. I'll just retype it, no biggie. Oh, but then I'm gonna need that degree measure again, okay. At least I can grab it from here. Okay, so these are both essentially 45 degrees, which means that the two side lengths are the same. Okay, so let's say that this side length was x. If this side length is x, then because the two opposite angles are also they're equivalent, this is 45 degrees and that's 45 degrees, then this side is also going to be x. Okay. Now, if this is x and this is x, we can use Pythagorean theorem to show that this side is x times the square root of 3. So let's see if I can put that square root. There we go, x root 3. So this ratio of sides is going to be the same no matter how big the triangle is. This works if your angle measures are 45 and 45. Okay? So there's one other one that's a 30, 60, 90 triangle that you may be familiar with from geometry. And I'm going to go ahead and sketch that out. I'll make the 30-degree angle the smaller one right here. So I'm going to try my best to get that at 30 degrees. Come on, almost. Y'all see what I'm doing here? Make that 30 degrees, right? Oh, boom, got it. Okay, so this is going to be 30 degrees, and then this side length will be 60. I'm sorry, this angle up here will be 60 degrees. So I'm going to go ahead and label those degree measures. Here's 30 degrees. Oh yeah, I forgot the degree symbol. I can just grab it from there. I don't know why I was looking elsewhere. So that's 30 degrees, okay? This angle up here is going to be 60 degrees. And then, of course, we have a right angle. So if you have a 30, 60, 90 triangle, oops. Let's see if we can just draw a little, there we go, a little square in there. Then we have a special ratio for our side lengths as well. So over here we had x, oh, wait a minute, whoa, back the truck up. That's not x root 3. Going too fast here. That should be x root 2. My bad. Yeah, because x squared plus x squared would be 2x squared, you take the square. Okay, so I'm sorry about that, guys. That should be x root 2. I'm working too fast here. So I'm going to try to slow this down a little bit. If this short length is x, then the hypotenuse is going to be 2 times x, and the longer side is going to be x times the square root of 3. So you get x to 2x and x square root of 3. So these ratios are going to help us construct what will be known as a unit circle, and we'll get there very soon. So let's try to solve these two specific triangles. So like if I have a 45, 45, 90, and I know the hypotenuse is 1, so this is a 45, 45, 90. I know these two sides are the same. If the hypotenuse is 1, then that tells me that 1 is equal to this x root 2 business. I'm going to use that to calculate what is x, and x will be this side right here. So if 1 is x root 2, then x will be 1 divided by the square root of 2. Now, I've been saying that we need to rationalize denominators when we get them. So let's go ahead and rationalize this. In this case, x would be, if I multiplied this by root 2 over root 2, I would get the square root of 2 over 2. Yeah, so that would be x, and so this value is going to be the same number on both sides of the triangle, okay, because we do have a 45, 45, 90, so here we go. These would be the side lengths. Okay, and on this one over here, we know that the hypotenuse is 1, so that's going to be our 2x. So 2x equals 1, so therefore x is 1/2. Now that will allow us to figure out the other two side lengths, because our short side length is 1/2. That would be the one opposite of the 30 degrees, so 1/2 goes down here. And then the longer side is x times the square root of 3. So if x is 1/2, then take that and multiply by the square root of 3, we will get root 3 over 2. Now these numbers are going to become very familiar to you over the course of the next few weeks. You will see these numbers like root 2 over 2, root 3 over 2, and 1/2 a lot. Okay, we will be practicing. Well, you don't even know what we're talking about yet, but we'll get there. But just know that you will start to become really familiar with these three numbers in particular. Okay, so this is just like a quick little review of geometry. It's important that you know these ratios, but what's more important is you start familiarizing yourself with these numbers. Because what we're going to do is we're going to use these right triangles to construct something known as the unit circle. Okay, so I hope you guys are ready for this. All right, so let's go ahead and define it. The unit circle is a circle that has a radius of 1 unit. That's why it's called the unit circle. If you want to know the equation for the circle, it's x squared plus y squared equals 1, right? The radius is 1, so here you go. Now, what's nice about the unit circle, it seems like, okay, well, who cares, right? It's a circle with a radius 1. But we can find trig values way easier if we're using the unit circle and we're working with some of the common angle measures that I'll show you in just a few minutes. So, go ahead and read this off. The terminal side of an angle graphed in standard position will intersect the circumference of a circle. So like, look at this little diagram. Let's say that this was theta right here. Okay, if that's theta, then you can see how the terminal side intersects that unit circle. It does keep going on forever, but it does hit that unit circle at some point. What's really nice about this is the x and y coordinates of where that terminal side hits the unit circle are equal to the cosine and sine values of that angle. In other words, this x comma y point that's right here on the circumference of the circle is equal to the cosine of theta. Ooh, let me see if I can throw in a theta here. Do I have one of those? Yeah, cosine theta and sine theta. So where this is really going is you're going to start recognizing some of these trig values simply by understanding where the terminal side hits the unit circle. Okay, you can find the values of any trigonometric function by drawing a little triangle and finding out where it hits the unit circle. So if we use those special right triangles, we can quickly identify 16 coordinates along the circumference of the circle that will help us evaluate trigonometric functions. So we're going to actually construct that right now. You can see, oh, that's it as far as the slideshow is concerned. The rest of today, what we're going to be doing is actually constructing a unit circle to help us throughout the whole year, really. And I know students that keep this into calculus and said that they're glad they had this. So this is a construction that you want to take care of, and that we'll go back to and kind of add notes to it later. But this is going to help us identify some of the some of the certain trig values that occur at common angles. So I'm going to switch over to my little dot cam over here. All right, let's see. Where's that button? Here we go. Oh, okay. I mostly got it on there. Let's get rid of that slideshow. There we go. Oh, see my little paper clip? Let's get that out of here. Okay, so what you should have, and if you're in class, I'm giving these to you, but if not, you can print these off at Schoology. I've got one piece of paper that looks like this. Can I zoom out a little bit, maybe? Nope, I'm gonna have to physically move the camera. Y'all bear with me here. All right, here's my desk. Okay, mouse, you don't need any of this. Okay, so you should have a piece of paper that looks like this. This is what we call the unit circle. We're gonna go old school here. I'm gonna actually write it down. This is our unit circle. This piece of paper is gonna be your new best friend, okay? Now, I'm also going to give you triangles. And again, if you're in class, I'm giving these to you. But if you're at home, like you're absent or something, you may just consider printing these out. It's not like fancy paper or anything. It's just printed on colored paper. You're going to need one 45, 45, 90 triangle. Cut that out. It doesn't have to be perfect. It just needs to be good enough. So here, cut that out. Trim this up a little bit, make it look a little nicer. This is something that we are going to use for quite some time until you guys really get your unit circle down. All right, fun stuff, watching Mr. Schuler cut. Hopefully you can fast forward through that. Okay, let's get rid of all that. All right, so this is my 45, 45, 90 triangle. We'll come back to that. I'm just gonna put it up here to the side. You're also gonna have one 30, 60, 90 triangle. So I'm going to trim this out. Again, if you're in class, I'm going to give this paper to you. If you're at home, you're going to need to cut this out. You'll find a copy of this on Schoology. So there we go. We got my 30, 60, 90. That's all I need here. Okay, so what we're going to do here is we are going to label these two triangles with their degrees and their side lengths. Now, because this is a unit circle, we are going to assume that the radius here is 1, okay? Because it's a unit circle, and that's how a unit circle is defined. So in other words, the distance from the center to the circumference is 1, no matter where you go along here. And what you're going to notice is these pieces are designed to have a hypotenuse that is 1, okay? So you can see if I put it like this, it's going to hit, it should hit pretty close to the circumference of the circle. All right, so let's label this. Okay, so let's start with the 45, 45, 90. And if you forget, let me pull that back up real quick. I still got it up on mine. Here is the 45, 45, 90, and we got the 30, 60, 90. And really what we're going to be looking at are these ones that we solved down here. Okay, so on this 45, 45, 90, we're going to label this 45 degrees, 45 degrees. We're going to label these sides root 2 over 2. And of course, the hypotenuse is 1. So let me hide that again. Let's get rid of that. And so I'm going to label it like this, 45 degrees. Okay. Here's 45 degrees. Here's my 90-degree angle. And my side lengths are going to be root 2 over 2 and root 2 over 2. My hypotenuse is just going to be 1. Now, yeah, I guess that's it. Okay, so now let's label the other triangle. Okay, so let's scooch this to the side. We got our 30, 60, 90. So you can look back at your notes, or I'll just pull it up here for just a second. We're going to be using this one down here, okay, this 30, 60, 90, with the hypotenuse is 1, because we're dealing with the unit circle. And the short side should be a half, and the long side should be root 3 over 2. So let's go ahead and label those. Oh, wrong one. Here we go. So the smaller one should be 30 degrees. The larger angle should be 60 degrees. Here's your 90-degree angle measure. This side length is 1. Here's a half. And then down here we've got root 3 over 2. Okay, so what we're going to do is we are going to go around the unit circle and use these two triangles two label points, and we're going to also figure out what the sine and cosine values are of each of these angle measures. So let's start, we'll go in order here. So we'll start with 30 degrees. So let's say I have it right here. Okay, so if I draw 30 degrees, my angle, my terminal side should hit right here. Okay, so here's 30 degrees. I'm going to mark that, 30 degrees. Okay, I'll come back and do the rest a little bit. All right, so let's pull our 45 triangle out. And we're going to draw 45 degrees. Okay, so here is 45 degrees. Okay. Now there's one more that we need in there, and it's 60 degrees. So you might be wondering, oh, how do I do this? Well, what I'm really going to need to do is I need to flip this over. So I think what I'm going to have to do is I'm going to have to label this triangle on the other side too. Here's 60 degrees. Here's 30. Here's my 90. So this will be 1, 1/2, and root 3 over 2. Okay. So I'm going to sketch out this angle measure. Okay, and this will be 60 degrees. Now, as far as the rest of the first quadrant, that's about all you need as far as degrees go. I'm going to label this one as 0 degrees, okay, and then hopefully you already know what's going to be up here. That's 90 degrees. So that, this point right here. Now that's the first quadrant. Let's do the rest of the quadrants. Now, you might be a little confused and think, okay, well, what am I going to do? I don't have a triangle that has an angle measure that's bigger than 90. We're going to use these and just basically reflect over what we had here. So like, if this is the 30-degree mark, if I reflect that over the y-axis, I have this angle measure here. I want you to think about what this has to be. If this is 30 degrees right here, then the angle measure would have to be 180 minus 30. That's going to be 150. Okay. Then if I go to 45 and I reflect that over, ooh, I'm going to need to mark this one too. Didn't do the back of that. So here's 45 degrees. 45 degrees, 90 degrees, 1, root 2 over 2, and root 2 over 2. Okay. So I'm going to draw this angle measure roughly. Close enough is good enough here. It doesn't have to be perfect. 180 minus 45 would be 135. So we're at 135 degrees right here. And then I'll bring back the 60. Okay. I'm going to flip that over and draw this one to the best of my ability. I'm not going to be too picky about, this looking perfect. Okay, so we got that, and let's see, 180 minus 60 would be 120. Now hopefully you're starting to kind of see a pattern here, and that is when I'm using the 30, 60, 90 triangle, these angle measures that I'm obtaining are all in increments of 30. 30, 60, 90, 120, 150. You already know this one is 180. And so what we can do is we can just keep adding 30 degrees to kind of fill out the other two quadrants. So if I add 30 to 180, let's see, I need one side to be on the x-axis. So I need to actually, I could do it like this, but really what I want to do is this one right here. Okay, so if I add another, because look, I've got 30 degrees right there. If I add another 30 degrees to 180, it's going to give me 210. And if I add 30 degrees to that, 30 plus 30 is 60, so I want to get a 60-degree angle going. +30 what was it, 210, it's going to be 240. 240 plus 30 is 270, although you already knew that. You can add 30 degrees again. So let's see, I want to add 30 degrees. Let's see how I can make that happen. Here we go. You kind of have to play with this triangle to get it to go where you want. Remember that one of the sides needs to be on the x-axis. Okay, no y-axis sides. All right, so this one's a little trickier. I'm going to contort my hands around here to make sure I can do this. Okay, and that angle measure would be 270 plus 30 is 300. We can add that one more time to get 330. And you're already aware of the angle measure that you get when you go all the way around. And just to make sure this adds up, 330 plus 30 is 360. So all the way around is 360 degrees. So there we go. We've got all the degree measures labeled. Now what we want to do is go around again, but label all the radians. Okay, so I'm going to switch pens here. So this might be a little trickier, but bear with me, okay? So 30 degrees is equivalent, let's start with one that you know, actually. 180 is pi radians, right? If we cut that in half for 90 degrees, that would be pi over 2 radians. Oh, wait a minute. We didn't finish all the 45s. That's all right. We'll come back to that. Now, a third, like if I want to go down to 30, a third of pi over 2 is pi over 6. So this is pi over 6 radians. So once you get that 30-degree increment, pi over 6, now what we could do is just kind of go through all those angle measures we just found and just add pi over 6 every time you increase by 30 degrees. So pi over 6 plus pi over 6 would be 2 pi over 6, which would reduce to pi over 3. Okay. 2 pi over 6, 3 pi over 6, which reduces to pi over 2. 4 pi over 6, which reduces to 2 pi over 3. 5 pi over 6. 6 pi over 6, which reduces to pi. We already knew that. I'm going to keep this train going. 7 pi over 6. 8 pi over 6. 9 pi over 6. I'm just reducing as I go. 10 pi over 6. And finally, 11 pi over 6. And the last one would be 12 pi over 6, or 2 pi. Now, I didn't do any of the 45-degree marks, so let's talk about that. And before we jump in with the radians, let's finish. This is my bad, y'all. I'm trying to go too fast here. Let's finish these 45-degree marks. So 180 plus 45 is going to be 225. If we add 45 to that, we should get to 270. If we add 45 to that, we should get 315. Okay, so those are the missing angle measures. I'm getting a little ahead of myself. Okay, so if we want to know what 45 degree is as radians, we know it's half of 90 degrees. So half of pi over 2 would be pi over 4. And what we can do is, just like what we did with the pi over 6s, just go around and add an extra pi over 4 for every 45-degree increment and reduce as you go. So this is 1 pi over 4, 2 pi over 4, which reduces, 3 pi over 4, 4 pi over 4, which is 1 pi, 5 pi over 4, 6 pi over 4, which reduces, 7 pi over 4, doesn't reduce, and all the way around would be 8 pi over 4, which reduces to 2 pi. So, okay, we're in good shape here. The last thing we want to look at here are these coordinates around the unit circle. And the reason why we want the coordinates is because, remember, these x, y coordinates are equivalent to the cosine theta, sine theta. Okay? These are equal. Cosine theta should be the x coordinate as we go around. Sine theta should be the y coordinate as we go around. So if I ask you what's cosine of 30 degrees, what you're going to report back is the x coordinate at that point. So how do we find these coordinates? We're going to use these triangles. Okay? So like for 30 degrees, for instance, I'm going to grab my 30, 60, 90 triangle, and I'm going to place it, right here. And if I want to know the coordinates of the point on the circumference, all I got to do is just look at these side lengths. Root 3, I know you can't really see here. It's not really focused very well. Yeah, this dot cam ain't very good. So you have to work with, maybe I'll just bring it down a little bit. Is that going to make it any easier to see? Yeah, it's just, I just wrote it really small here. But anyway, yeah, so we got root 3 over 2, 1/2. So this coordinate is going to be root 3 over 2, comma 1/2. How are we going to use this coordinate? Well, cosine of 30 degrees is root 3 over 2. This is cosine of 30, or cosine of pi over 6. Okay? The y coordinate is sine. And we'll talk about the other trig functions as well, but I want you to really understand that relationship there. For 45 degrees, I'm going to break out my 45-degree angle measure. Say okay. Cosine, let's think about it. Adjacent over hypotenuse, right? Adjacent over hypotenuse would be root 2 over 2. So the coordinate here is root 2 over 2. Sine, opposite over hypotenuse, root 2 over 2. For the 60-degree mark, cosine, adjacent over hypotenuse would be 1/2. Sine theta would be opposite over hypotenuse. That'd be root 3 over 2. So we've got these coordinates that will give us the sine and the cosine values. Now, you don't have to memorize them as coordinates. You can just put your triangle down here and recognize that, like cosine, for instance, is adjacent over hypotenuse. So 1/2 over 1 would be 1/2. So these can really help evaluate these trig functions if you're given one of these common angle measures. Now, what about the extremes? We don't have a triangle for those. But we do have coordinates that should be pretty easy to sort of figure out, right? Because the radius is exactly 1. So this coordinate right here should be 1, 0, right? The x is 1 and the y, it's not going up and down. Similarly, this coordinate up here should be 0, 1. Now, why that is important is it allows us to evaluate things like cosine of 90 degrees. Cosine of 90 degrees, well, cosine's the x, so cosine of 90 degrees is 0. Sine of 90 degrees is 1. Cosine of 0 is 1. So sine of 0 is 0. Now, once you have that first quadrant down, the rest should be pretty easy to figure out. And the reason why I say that is because all these points are just going to be reflections of these ones over the y-axis. So like, if I know that coordinate and I flip this over, these side lengths are basically going to be the same, right? It's 1/2 root 3 over 2. The only difference is in quadrant 2, the x value is negative. So what you can do is you basically can reflect these points over, right? I'm going to erase this, but just so you can see visually, temporarily, is, I'm basically taking these points and I'm reflecting them over so that they're going to be the exact same coordinate, but the x is going to be negative. So this point over here, negative 1/2, comma positive root 3 over 2. This point is going to be the same as this, except the x is negative. Negative root 2 over 2, comma root 2 over 2. And then if I reflect this one, I get negative root 3 over 2, comma 1/2. I'm trying to clean these up, these 2's. Okay, so they're the exact same coordinates as the first quadrant, but the x is negative. And then this point down here, we're just going 1 unit to the left, so that should be -1, 0. So that's how I get all these coordinates in the second quadrant. If I want them in the third quadrant, I'm going to reflect again, but instead of reflecting across the y-axis, I'm going to reflect across the x-axis. So I'm going to get very similar numbers. Now, at the beginning of this lesson, I told you, hey, you're going to be seeing these numbers a lot, right? In particular, 1/2, √3/2, and √2/2, and now you're hopefully seeing y. Okay, we're seeing them all across this unit circle. So I'll just do one arrow here. I don't need to draw the rest, but basically we're going to take that point and reflect it down. So I'm going to take this coordinate and I'm going to write it here, except in quadrant 3, both x and y are negative, right? So down here I've got this coordinate. Let's see if I can fit it up here. -√3/2, -1/2. Right? And you can check with your little triangle. Yeah, put the triangle on there, and you can see -√3/2, -1/2. If I do the 45, 45, I can see it's -√2/2, -√2/2, which is what I would have got if I dropped this down. At 240, same kind of deal here. I'm going to get -1/2, -√3/2. And 270, this is just 1 unit directly down from the origin right here, 0, 0. So 1 unit down would be 0, -1. All right, we're almost done here with this construction. We've got the degrees, we've got the radians, and we're almost done with the coordinates. We're going to do one last reflection. You can either reflect this way or you can reflect down from the first quadrant. It doesn't really matter. Just make sure that when you're in quadrant 4, your x is positive and your y is negative. So just in the interest of fitting everything here on the screen, I'm just going to start reflecting my third quadrant over to the fourth. So in other words, like this coordinate will be the same as this coordinate, except the x should be positive. So this point's going to be 1/2, -√3/2. This point will be √2/2, -√2/2. And then this one will be √3/2, -1/2. Now again, the whole point of doing all this, y'all, is so that I can ask you, if you're looking at this and I say, what's cosine of 4π/3? Your eyes should go to 4π/3. If you don't remember the coordinates, that's okay. You're going to put your triangle down in such a way that we can get that hypotenuse going in the right direction. And if I know that, what was my question? Cosine of 4π/3. If I know that cosine is adjacent over hypotenuse, then I know that it's 1/2 over 1, except the 1/2 is negative. So cosine of 4π/3 is -1/2. And if you know the coordinates, that makes everything a lot easier. You don't have to put the triangle up. Then you can just see, oh, I know that cosine is the x and sine is the y. So yeah, a couple things that might be worth writing down here. I'm actually going to erase this because I want to give you a better way of looking at this, okay? So cosine theta, right? So cosine's adjacent over hypotenuse. That's going to be your x-coordinate. Sine theta will be your y-coordinate. Tangent theta is going to be opposite over adjacent, right? So opposite over adjacent would be like, well, let me give one that's not the same. Would be like 1/2 over √3/2. That would be the y-coordinate over the x-coordinate. Now for your reciprocal functions, like secant, so secant theta is going to be the reciprocal of the x-coordinate. Now don't always just try to like do 1 divided by the x. I think that'll complicate things. Just flip the fraction. So like if I want secant of π/3, just flip this fraction. It'll just be 2. Okay. Cosecant of theta is the reciprocal of y. And cotangent of theta is the reciprocal of tangent, so that's going to be x over y. So that's pretty much it for today, y'all. This is a lot of information to take in, and I'm hoping in the next couple of weeks you're going to have this whole thing memorized. That seems like a tall order, and what I mean by that is for these 16 common angle measures, my tool's out the way, you're going to have the degree, the radian, and the coordinate memorized for all these. Now, you know, use these triangles to help you out, but there are tricks, sort of tricks to get this all down. Like for instance, you know, you could do your angle measures like 30, 60, 90, 120, 150, like just add 30 every time, like going all the way around, and then add 45 going all the way around, and that'll give you all these 16 common angles. For the radians, same kind of strategy. Like if you can just remember that 30 degrees is pi over 6 and 45 degrees is pi over 4, you can do the same sort of addition trick where you're just adding a pi over 6, like pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and just reduce as you go. With the pi over 4, same idea, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and you just keep going. For the coordinates, use your triangles in the beginning to figure out, like, okay, what are these actually equal? And then we'll use those to evaluate these. Now today, you know, we'll practice more evaluating next time, but for today, what I really want to make sure you can do is fill out this unit circle. That's it. And then start to make that connection between, you know, cosine, for instance, being adjacent over hypotenuse. You know, notice this is always 1, so it's just the adjacent side, it's just the x. You know, keep in mind, you know, so cosine should make that association. That's the x coordinate, sine is the y, and so forth. So that's about it for today. You know, hopefully you had fun making this little construction, and I'll see you guys next time.